Okay, 11:6. We're almost done with chapter 11. We're still talking about circles, and today we're going to be talking about segment relationships in circles. So segments, remember, are parts of lines. So we're not going to be talking about degrees. Our answer is not going to be in degrees. We're going to have actual segment length today. So you're going to learn to find lengths of segments formed by different types of lines. So let's remember again what a secant segment looks like. We have a circle. My beautiful circle. A secant is a line that touches the circle how many times? Twice. An external secant segment is external means outside. So this part, the part outside the circle, would be an example of an external secant segment. And then a tangent segment. Tangent is also a line or a line segment, and it hits the circle only one time. So it's important that you remember that secant hits it twice, and tangent only hits the circle one time. Okay, so the first type of question we're going to do is not talking about secants or tangents. We're actually talking about chords. And remember, a chord is just a line segment that's inside the circle and hits it two times. So this is an example of a chord. Okay, so the first theorem says chord-chord product theorem. So chord means we're talking about one of these lines. Another chord means that we have a second chord, and product means to multiply in math. So chord-chord product theorem. If I give you two chords and they intersect at the same spots, okay, so it's important that it looks like this and not like this. Okay, this is not going to work. That does nothing for us. The chords need to intersect, and when they do, it cuts it up into four pieces. And what's going to happen is you take the two pieces from one chord, multiply those together. So for example, CE times ED, CE times ED, it's going to equal AE times EB, AE times EB. So if you wanted to label this segment 1, segment 2, segment 3, segment 4, this thing is saying 1 times 2 will equal, well, that's not going to work. I don't know why I did that. Let's say these lengths, excuse me, are like 2, 3, 1, and 6. These two are the same ones, so you'd go 2 times 3 equals this chord. The pieces are 1 times 6. So 2 times 3 does equal 1 times 6. Okay, so that's like what we're going to do first. And remember, that's when we have chords. So if you look at number 1 and 2, these are both chords. So we're going to use the chord-chord product theorem. So all you have to do is multiply 2 parts of 1, so that's 7 and 10, is going to equal the 2 parts of the other one, so 14 times x. So to solve for x, this is 70 equals 14x. Divide by 14, and you get your answer. So what's 70 divided by 14? 5. So x equals 5. Okay, and again, if you want to plug it in to figure it to make sure it works, you're more than welcome to. Okay, so you're going to do the same thing for number 2. Number 3. Archaeologists discovered a fragment of an ancient disk. To calculate its original diameter, so remember diameter is the middle of the whole circle, so let's say here's the center C. They drew a chord AB and its perpendicular bisector PQ. Find the disk's diameter. Perpendicular bisector, so important, because that means that it's going to cut these into two congruent pieces. This is bisecting this line. So that means if this one's 6, then guess what? This one has to be 6 as well. And we know this part is 3, and we want to know what the rest of it is. So we're going to call that x. Now the diameter, this is what we're really looking for. Diameter is this whole thing. So I want you to write down that the diameter is going to be that 3 that we do know about, plus the leftover, the part that's missing. So we'll call that x. So this is what I want you to remember, but in order to figure out what the diameter is, we need to solve for x. Okay, well, these are two chords, so we're going to use the chord-chord product theorem. So that says 2 parts of one chord multiplied together are going to equal 2 parts of the other chord multiplied together, so 3 times x. And then we just solve. 6 times 6 is 36. Divide by 3, and we get x equals 12. And some people are going to stop there, but that's not the diameter. The 12 is just the missing part of the disk. If you add another 3 to it, that means that the diameter is actually going to be 15 inches. All right. So number 4, what happens when the radius or diameter bisects a chord? It's going to be perpendicular, and it's going to cut it in half, which is what it means to bisect it. All right. So we just learned our first thing. Chord. Remember, you multiply the two pieces together. Second thing is when we have two secants. So secant product theorem. Well, okay, secant means we have one secant. Remember, that's a line that hits a circle twice. Once, twice. And then we have another secant. Here's a line CE. That's a secant. So it hits it once, twice. Sweet. That means product means we're going to multiply again. So all we're going to do is we're going to say the outer part, BE, the external part, times the whole thing, AE. So I want you to write that we're going to multiply the external part times the whole secant is going to equal the external part of the other secant times the whole secant. So if you look here, external is BE, and the whole thing is AE. And if you look at this other secant, the external part is DE, and the whole thing is CE. Okay, so this one's a little bit trickier, but we're still just multiplying. So number 5, it says find x. Okay, we have two secants because it hits a circle twice. So that means we're going to take the external part, that's 8, and multiply it by the whole thing. Well, we're just adding it, so that's 8 plus x, or x plus 8. That's the whole thing. And we're going to do the same thing over here. So the external part is 7, and the whole thing, you add them up. 9 plus 7 is 16. So this is the tricky part for some people, that it's x plus 8. Remember, you're adding in the parentheses, you're adding. Okay, just like we did here, we added. Okay, so 7 times 16, that's 112. Over here, we're going to have to distribute this 8. So 8 times x is 8x, and 8 times 8 is 64. And then we just have a multi-step equation. So we subtract 64 from both sides. And then we get 8x equals 48. And then we divide by 8, and we get x equals 6. All right, I know that one was a tricky one. So I'll do number 6 with you one more time. Okay, so find z. These are two secants. So I'm going to do this line first because I think it's easier. Remember, we take the external part first. So that's 9. We multiply it by the whole thing. Remember, we're going to add. So 30 plus 9. This is the whole thing. And that's going to equal the other secant, the external part, which is 13. That's the external part, times the whole thing. Remember, that's when we add. So it would be z plus 13. Notice in the parentheses, we're adding. Okay, so we have 9 times 39 equals 13 times z plus 13. And then we're going to distribute and multiply it. So 9 times 39 is 351 equals 13z plus, I think that's 13 as well, 169. Subtract the 169 from both sides, and we get 182. So we have 182 equals 3z. Divide by 3, and you get z equals 60.66 repeating. All right. We are moving and shaking. I don't know why this is called quadrilaterals inscribed within circles. That's wrong. That's called a secant tangent, but I'll fix it later. Okay, so secant tangent product theorem. We have a secant, we have a tangent, and we're going to be multiplying to figure out how long these segment lengths are. So we're almost done. I'm going to do number 7, and then you're going to do 8 in the exit question, okay? So this one says, if we have a secant, if you notice AC, that's a secant, what you're going to do is the same thing we did last time. Every time you see a secant, it's the same thing. You're going to take the external part, and you're going to multiply it by the whole thing. Okay, so nothing has changed. For secants, it's always external times the whole. And what did we know? What did we learn about chords? Chords, it's the two parts multiplied together. This is what I would write down for my notes because this is going to be an easy way to remember. Secants, you don't multiply the external times the whole. Chords, you just multiply the two parts together. So for example, if it was like this, you would multiply this part times this part equals this part times this part. Okay. Tangents are a little bit different. Tangents, if you look, it's just CD. There's only one part. So all you have to do for tangents is square it. So those are the 3 different types of line segments, and those are the 3 things you do to figure them out. So, okay, let's try 7. Find x. Okay, this one, we have a secant. So for the secant, remember, it's going to be the external part times the whole part. So 5 plus 15. So that's external times the whole. For secant, it's just, I'm sorry, for the tangent, that's this part, all you do is square it, equals x squared. So we have 5 plus 15, that's 20, and 5 times 20 is 100, and the square root of 100 is going to be 10, so x equals 10. All right, I'm going to do 8 for you too, because this one's another tricky one, and then you guys can do the exit question, and that's it, okay? Okay, so for 8, it says find y. That's this part. We're still going to take the tangent part, and all you do is square it. So that's 10 squared. This is tangent over here. For the secant, remember you do the external part, that's 7, times the whole thing. So 7 plus y. Okay, so let's see what that gets. 10 squared is 100, and for here you're going to have to distribute. So 7 times 7 is 49. 7 times y is 7y. And now again, we just have a simple one-step equation, or multi-step equation. You subtract the 49 from both sides, and you get 51 equals 7y. And then you divide by 7, and you get y equals some weird number, like 7.28. I'll do 29. Did I do something wrong? 7, external part times the whole thing, 7 plus y, 10 squared, 7 times 7 is 49, 7 times 7y, okay. No, I don't think I did my math wrong. All right, cool. So then this is the last thing you're going to do, and you're done. And remember, I want you to know that there are 3 different line segments, so there are 3 different ways to find those line segments, okay? So it's really important that you remember which line segment goes with which formula. Awesome.